I'm Shelbee Eigenbrode. I am an AI/ML Specialist Solutions Architect at Amazon Web Services. And I'm based out of Denver, Colorado. It's my first time in Canada, although I didn't reserve enough time to actually explore, so I need to come back. But I'm based out of Denver, Colorado, and I spent pretty much the majority of my time in the domain of MLOps and helping customers implement MLOps practices. Now, in this session, we're going to go through the top 5 lessons learned that I've learned and we've learned as an organization in helping other organizations and teams adopt MLOps practices. And full disclosure, I completely cheated because I had a really hard time narrowing it down to just 5 top lessons learned. So you'll notice within the 5, there's some high-level categories, there's some mini lessons learned within each of those. But we'll go through all those lessons learned. We'll go through some of the recommendations as well so that you don't have to relive or relearn those same lessons that we've learned after helping several customers implement MLOps practices. And we're really focusing even more specifically on implementing MLOps practices at scale. So to start off with, what are these lessons learned based on? So why are we here, right? A little over 4 years ago, I started working really heavily in the domain of MLOps on different patterns, working with organizations, working with teams on how to optimize their processes to ultimately deliver models to production. And over that time, I've been able to learn a lot of what does work and then what doesn't work between working across a lot of different customer segments. So from startups to mid-sized businesses to digitally native, born on the cloud companies to enterprises to really heavily regulated enterprises as well. And in addition to being able to have that opportunity to work across customer segments, I've also been able to work across industries from retail, financial services, healthcare, agriculture, just to name a few. But being able to really kind of understand the different challenges that are inherent to the customer segment as well as the different industries within those customers. So I've personally learned a lot in that time, but I've also had the advantage, I guess I would say, of learning from other colleagues that are also working in the same space and implementing MLOps practices at scale for customers. So that being said, I do tend to spend most of my time with larger digitally native businesses or larger enterprises, heavily regulated enterprises. But most of the lessons learned can really be kind of applied across the board, right? Even if some of the inherent challenges that you run into are a little bit different between segments and industries. So we all know that MLOps, right, builds on DevOps practices, and it's really a set of practices that span the intersection of people, process, and technology. And as we go through the lessons learned, you'll notice I hit some areas a little bit harder than others, but then you'll notice that really, towards the end, hopefully, you see more of it coming together with all these practices, the intersection of these practices really kind of coming together in how we optimize the process to build or manage projects, build, deploy, manage, and govern machine learning models and machine learning workloads in production. So that being said, let's get into the first lesson. So we're all technologists, right? And it's really easy to start with technology first. How many people in the room start with technology first, typically? You're way better than me, because I tend to, because it's exciting. I love the technology that exists. So I have to be very intentional and pull myself back to the process, right? Because the technology is exciting. But within that, this is our first lesson learned, is to start with process first. And the reason you may be wondering, start with process first, or maybe you're like, wow, that's totally obvious, is because there's a lot of activities that it takes, right? This is just a high-level machine learning workflow, different steps there, but it's obviously not all-encompassing. So it takes a lot of different steps to ultimately bring a machine learning model to production, as well as to incorporate it with other business processes, other business applications. And to do that well, you really have to understand what your current process is here, and then understand what are the gaps in your current process, what needs to be fixed, and what needs to be added within those. To ultimately be able to create that repeatable and reliable path to production for your models. And because there are so many activities within here that need to happen, right? And from framing the machine learning problem, down to training your model, down to building, deploying, all of those different things. It's really tough to do, right, if you have a lot of gaps in the process. And we're not going to go through every process gap that could be potentially here. What we're going to do is hit on the most heavy ones that we see that create bottlenecks that impact your ability to deploy rapidly, to be able to manage your machine learning models. So to start with, you need a process in place to be able to identify and prioritize machine learning projects. And the reason for that is, and what this usually means really is having a process in place that allows you to identify which projects should be prioritized. So a lot of times when we're working with organizations, we'll go into kind of the art of the possible session, especially organizations that are new to machine learning. And they're really fun because everyone gets really excited about machine learning, what all the possibilities are, how they can use machine learning to drive business outcomes. But a lot of times, being able to scale machine learning as part of like your really core business strategy, it really takes an intentional and strategic process where you're looking at things like data readiness, what data is ready, what data is available for my machine learning problem, what's the business impact if I do solve this machine learning problem, and then what's the machine learning applicability here. So this is just kind of a general guideline. There's different models, different methods out there to be able to identify and prioritize the right projects, but it should be intentional, right? Because what this allows you to do is also identify where you can have quick wins. So, and when I say quick wins, I mean there's a lot of machine learning problems that can be solved through common machine learning techniques, pre-trained models, AutoML. So take advantage of those quick wins when you can, because a lot of times data scientist teams are really trying to prove their value very early. So there are a lot of quick wins that can happen when you have a very purposeful, intentional, strategic plan for how you're going to identify and prioritize your projects. The other key reason for having this in place is because, if you have projects that a bunch of different teams are working on, they all have different priorities, you're going to be constrained on resources, right? So to be able to protect your most precious resource, which is typically your people, you want to be able to focus their time on the efforts and the projects that are most strategic to you and your business. And I talked about those art of the possible sessions, right? And within those, they're great. Like I said, they're fun. They're a great way to get started. But a lot of times we kind of have to take it back when we look at the overall machine learning strategy, because just because you can do something with machine learning doesn't mean you should. It also doesn't mean it's worth the return on investment. So an example here is I was working with a customer, and they had a really large NLP problem. It was a problem that had a lot of focus inside the organization. However, when we looked at it, it was an NLP problem that was going to take people with far more degrees than I have to solve. So it was going to be an expensive problem to solve. It was also going to take up resource time to solve that problem. But when we ended up sitting down with the business stakeholders, what we ultimately ended up identifying is that this was a nice to have. It wasn't required, right? And we knew that from a data science perspective, it was a problem that maybe could be solved. So it's really interesting from a research perspective, but there was no guarantees, right? It was going to be a lot of money sunk into this problem. So the point with that story is really making sure that your priorities are aligned, right? And part of that is making sure that you clearly identify the business value up front. And to do this, you really need to identify the key metrics that you're going to use to measure success. And this is not just the metrics for model performance, right? That's one aspect of measuring impact, but also the metrics that you're going to use to measure impact and success to the business. What data do you need to collect to be able to do that? And you need to be very intentional in that, right? Because what happens there is a lot of times when you start to get very intentional on what defines success for that project, it also helps you not only prioritize that project, but also set expectations for that project. I've worked on several engagements where the business owner was looking at 100% accuracy as a key success metric. Now, yeah, that's a challenge, right? So that kind of reverts back to that previous slide. The ML applicability there it's not there, right? If you need 100%, machine learning is not for you. So really kind of being very intentional and identifying those key metrics up front also helps you set expectation with your key stakeholders, right? You're not going to get 100%. What can you get other than that, right? Or is it not worth it in that case? Is it one of those projects we just don't take on? And so this first kind of set, like I mentioned, I cheated a lot. But this first set of kind of mini lessons learned within Start with Process are really about the fact that MLOps does build on top of DevOps practices, right? Even in regards to your product or project management, your process for picking your backlog, identifying, prioritizing the efforts to work on. But it does include those aspects that are really unique to machine learning. And you can see here, as you scale your machine learning across use cases, across teams, you really do need that process in place to be able to pick and prioritize the right projects. And it doesn't have to be a super heavyweight process that, requires a consensus of 80 million people, but it does have to be purposeful, it does have to be intentional and strategic. So in the next lesson learned, you need to ensure that you have a repeatable data strategy that includes AI/ML. This one is a very common bottleneck that we see, and it's where data scientists have problems getting access to the data they need to actually build their machine learning models. And getting access in a way that also is acceptable with IT, right? So in terms of getting access in a way that's governed, still keeps the data secure, and also doesn't impact the reliability of your model lineage and your governance strategy as well. So without a data strategy that includes machine learning, you'll just never be able to find a way to be able to reliably and repeatably scale. So it's one of the first things that we always cover with organizations and with teams. And when you're looking at building that strategy, you want to make sure that you have a way for data scientists to access the data they need, so they are able to discover, access that data. And this doesn't have to be, and it really shouldn't be, a big free-for-all, right? You want to make sure that it includes a central data catalog, that they have access to governed data sets. So I would say this is probably one of the top bottlenecks that we see, and top complaints that we run into with data science teams is being able to get access to data, and it's especially challenging in heavily regulated industries. Anyone in the room have similar challenges in their own organizations or have seen it? Perfect. A lot of you are very lucky. You must have a great streamlined process in place. It is just one of those common bottlenecks that we see. And what I've found is really kind of key in those situations where it is a bottleneck is, one, having the automated controls in place, but also in a lot of these situations, it's about communication and establishing those controls early. So as an example, I have an engagement with a financial services organization where rightfully they're worried about data scientists using live data, using data that has sensitive information in it, PII data inside of it, and it's a valid concern, right? But however, when we actually sat in the room with the different teams that were kind of needed and all these different handoffs, what we really uncovered is that most of those machine learning use cases, they don't require that PII data. They didn't require any sensitive data with it. We could easily develop a process to then create curated data sets for those data scientists that either completely remove PII data or encode that data. So basically, it's just making sure that you have a process in place so it doesn't become a bottleneck, and then automate the controls where you can as well. And again, if you have a small team with a few data scientists, the ad hoc approach may be okay. But when you start to have teams that have hundreds, thousands of data scientists, that ad hoc approach becomes very unreliable, for one, but it also introduces some inherent risk to your data, as well as to your model governance and your model lineage strategy. So the next one, this kind of leads into the previous one from data, but this is about giving data scientists access to environments so that they can do their experimentation, they can do their development, they can get access to the resources they need. So not only the data they need, but also the resources. Obviously, machine learning takes a lot of heavy compute, a lot of storage. So data scientists often need access to environments that have that heavy compute available and also have the storage that they need available. So in this one again, you typically don't want to enable 200 data scientists with carte blanche access to the most expensive compute that's out there. So what this one's really about is enabling data scientists with access to the resources they actually do need, but also establishing controls to make sure that you're taking care of things like cost, security, governance, all of those different things. And the technical implementation of this can vary, right, depending on the platform, depending on the cloud, depending on the products that you're using. It typically is a combination of like infrastructure as code, configuration as code, policy as code, where you're creating these environments for data scientists. One example here is I work with customers who they actually establish controls. They have these environments, self-service data science environments. But what they do is they limit the access to GPUs to only those teams that need it, because maybe they're working on a ML use case that kind of justifies the GPU usage. And so what that allows them to do is give access to those data scientists that do need it, while still maintaining cost controls on groups that potentially don't need those GPUs. And let's face it, if you're like me, you may pick the biggest compute because you're like, yeah, I might need it, right? So it helps kind of with those cost controls and ensuring that there's a process in place for that. Oh, sorry. That should have been the picture you saw. Oh, sorry. There's someone taking a picture there. So this kind of brings us into the next category, which is making sure that you have a repeatable and reliable path to deployment. I would say this is the second most common bottleneck that I see next to access to data, is having a consistent and reliable process to be able to deploy your models to production. And really, and this may sound silly, right? We've heard it a million times. This is where having those cross-functional project teams comes into play, as well as having those shared goals and priorities in place, especially in cases where you have multiple personas that are really responsible for the tasks within this workflow. If those people don't share common goals, common priorities, and every handoff is manual, it's going to be really tough to scale, and it's going to be really tough to have any degree of reliability within your process as well. An example here, sorry, I have a lot of examples, but one example here is an organization that relied on a central DevOps team for deployment, and this is actually a really common scenario in large enterprises. I don't know, do any of you have that similar situation? Yeah, and it's a super common scenario. However, the same team didn't have necessarily a machine learning background. They hadn't had time to kind of do any training. But more importantly, they really didn't have the same goals and priorities. So what that meant is all the people on the left-hand side had one set of goals and priorities. The person on the right-hand side had a completely different set of goals and priorities. So if you're relying on a central DevOps team, a central cloud platform team to deploy your model, and they're already overwhelmed with their existing workloads, right? Because they're probably supporting the rest of the business as well. It's going to be really tough, and the likelihood of getting your models into production integrated with these existing business applications and processes is really low. So this kind of ties back to having those same shared goals, same shared priorities. Now you'll notice here, another key lesson you'll see is it says reduce manual tasks and handoffs where desirable. Because of the nature of ML, it's very possible and very likely that you'll have some manual gates that you want to keep in place. And taking another real-world example again, let's say you have a model that takes days to train on multiple GPUs. That's an expensive training cycle, right? So even if some degree of model drift is detected, it's possible that you still want to have some additional manual gates in place there to evaluate whether it makes sense to go ahead with a new training cycle given the cost, right? There has to be a balance between the cost as well as the benefit of retraining that model again, especially if it's, days, months. Some models are pretty heavy. So as a result, you just need to ensure that your end-to-end process reduces those manual handoffs and tasks, not only where possible, but also where desirable. I know we talk about continuous training. It's an amazing buzzword. It's very valid in a lot of use cases, but it's not valid in all use cases. So just something to kind of be aware of. And then finally, inside process, we talked about identifying those key metrics to measure the impact of your model, right? So the model relative to the machine learning problem you're trying to solve, but also the key metrics that identify the impact to your business as well. So you need to make sure that those feedback loops are in place to be able to provide that level of transparency to all the personas that are kind of ultimately responsible for this entire end-to-end process. And one note, we talked about reducing manual handoffs is making sure that those feedback loops are incorporated into your normal business processes. So we see with a lot of companies, and this is worthy of a whole separate discussion, but where it makes sense in ensuring that transparency. It could be just general alerts to some dashboard, but it could also be integrating with existing systems that you have in place for issue tracking, change management tracking, that sort of thing. So just making sure that you integrate those feedback loops into the mechanisms that provide the most transparency. So I just went through a lot of lessons learned under process. I'm sorry, I cheated, clearly cheated. It was just a massive lesson learned. But it really is a place where we see so many bottlenecks occur, so I felt like excluding any one of them, and it wasn't all inclusive of all the bottlenecks that can exist, but I felt like excluding any one of them really wasn't kind of telling the whole story, so I apologize for cheating. But let's move on to the second lesson learned, and you guessed it, you can't scale with people issues. So the biggest call out here, and don't worry, it's not embedded into like 50 different slides like process was, but the biggest call out here is we talked about the multiple personas that are really required and involved in the end-to-end machine learning lifecycle. So it's important that that collaboration exists. It's important that those shared priorities exist that we talked about before. It's also important that you're speaking the same language between the teams. And this is often difficult, right? Because with MLOps, you're bringing in different personas, right? So a data scientist may not have, if it's a classically trained data scientist, which I call classically trained, they may not have an IT background. Similar with DevOps teams or ML engineers, they may not have the depth in an ML background, or an ML background, right? Or like how to monitor a model. So, and I remember in one of the very first engagements I had, it was with a company that does a lot of research. And it was a workshop, and in the room we had data scientists, and then we had the DevOps team. And right when I started talking about model deployment, someone raised their hand and said, like, what's an endpoint? What's an API? And I realized at that point, I needed to change my language and how I spoke depending on the persona or the person that was in the room, because, it's not common that, it's very common that you're kind of speaking different languages based on your domain of expertise. So really, in terms of solving this one, what we find, and I spend a lot of time in this with organizations today, is providing some really high-level knowledge across the personas, so everyone who's involved in getting a model out the door, providing them some really high-level basic knowledge of the machine learning development lifecycle so that everyone can kind of start to speak the same language. The other challenges I've seen is in organizations that over-index on hiring. So I've worked with organizations that have an enormous amount of data scientists, and then you come to find out there's a single data engineer. And that makes it really tough, right? A single data engineer that's used to working with data at scale, that becomes really challenging. So now, these personas are just that. Like, don't take too much stock in the personas. It's common for one person to play many roles. How many of you play many roles on this list today? Yeah, it's super common. And in fact, we've even changed a lot of our language to focus a little bit more on jobs to be done versus personas. So if you find your teams getting super hung up on the persona discussion, try swapping that language to jobs to be done, right? Because it doesn't matter who does it, it needs to be done. So just focusing on the job that needs to be done, who's gonna do that? That being said, having dependencies between multiple people is really common, even if you do have, people playing different roles. So it is very common for multiple teams to be involved and there to be some degree of handoffs that you need to look at automating and reducing those manual handoffs, especially in companies like large enterprises. However, startup, right? You may see more of kind of the full stack unicorns in startups. Is anyone that today? Or would you consider yourself that? Yep, that's a hard job. Kudos to you. But it's a hard job. It's not easy. And it is relatively rare to have that because there are benefits, right? Reducing the number of people, the number of handoffs certainly has benefits in terms of the speed that you can go. But it is really, really difficult for that person to maintain enough kind of domain knowledge within each of these areas to do that. So what we typically see is generally a mix of people performing all of these different jobs to be done across the machine learning lifecycle. So a few things to wrap up the people aspect. We talked about setting expectations early with stakeholders through clearly defined success metrics. We also talked about, the need for collaboration early, cross-functional collaboration. I can't tell you how many models I've seen that just kind of get thrown over the wall and they just sit there for a long time because there wasn't that early cross-functional collaboration happening. And even looking at some cross-training, and it doesn't have to be, there's no intention for a DevOps person to become a data scientist or a data scientist to become a DevOps person, but just some cross-training so that everyone can kind of speak the same language. And then also ensuring, once again, those shared project goals and priorities. I know I harp on that, but it is super key. So we looked at some of the top lessons learned in people and process, but now let's move on to the third one. So our third lesson learned is probably in the area that we all love, right? Technology and technical implementations. Not only for the environments for your experiments, but also for the process to deploy models as well as govern models in a way that's not only repeatable and reliable, but also ensures core practices like model governance, as well as model lineage, as well as providing that end-to-end traceability in your machine learning pipelines. So I can't tell you how many times I've had requests from someone to put together a very prescriptive MLOps pattern that just can be used kind of globally across the board. However, there really is no golden pattern for how you implement your machine learning pipelines, right? There's common core components that I think we all agree at this point, even though MLOps is still relatively immature in practice. I think there's core components that we all agree that need to be in place, right? Whether it's feature store, model registry, all of those common things. However, the technical implementation choices, the tooling choices underneath, there's a lot of valid options here. And there really isn't a golden pattern, right, in terms of actually detailing it down to a technical architecture. It can get very prescriptive once you meet with an organization, understand their current skill sets, understand their existing tooling, all of those different things. But it can vary quite a bit based on all those different factors. So there is a lot of right answers here. And these choices really typically vary depending on those factors I mentioned, whether you have existing solutions, existing tooling, all of those different things. And even the steps inside your workflow and inside your pipeline may look different depending on the type of model it is, depending on the use case, depending on any number of factors. It can look very different. So even though those core steps, those core components remain the same, the technical implementation can certainly vary, and that is okay. But once you understand those core components, so the things like feature store, model registry, all those different things, the technical choices that you make is really dependent on your teams, your organization, what makes sense for your business. And if we look at the different categories that we see, and these are just high-level categories, the broadest range of choices, right, that are available. First, you have packaged or managed solutions, and they can be end-to-end in terms of meeting your entire needs, your entire workflow end-to-end, packaged, managed. You're not managing any servers. It can also be a specific component within that workflow is packaged and managed, right? And that's more in the hybrid case. But in these cases, when you're looking at packaged managed solutions, the operational complexity and management tends to be relatively low, whether it's packaged product on like SaaS-based offering, or if it's packaged, you're running your own server for that particular offering. However, the flip side is that there may be less flexibility and control within it, and it may not be as extensible to fit every machine learning use case that you have, or be able to scale without some operational issues as well. It isn't always the case, but it really kind of depends on the solution and your needs there. The other end of the spectrum is completely do-it-yourself, right? Where basically you're running your own servers, you're custom developing your own components like feature store, model registry. And in this case, there's much more operational management, right, and overhead that comes with that. And you also need to worry about things like scaling, availability, managing, securing, all of those different things. You have to worry about that underlying infrastructure there as well as any custom development that's required to kind of roll and run your own components like feature store or model registry. You'll also likely require more people, more skill sets to be able to support this. But the flip side is you have more flexibility, you have more control, you can build a completely custom solution for your use case in your organization. Finally, and this is a very common one, this is where I see most people land, is in the hybrid world, right? Where the hybrid approach is typically where you're using a combination of managed or packaged solutions in combination with some do-it-yourself solutions as well. And you're creating the integrations that are needed, right, to stitch together these end-to-end workflows. With this, you kind of see you sit somewhere in the middle, right, in terms of flexibility and control, and then the management and overhead. Again, there's no single right answer. So just to kind of wrap it up, a couple of tips in terms of making technical choices. I spend a lot of time with organizations on tooling choices, tooling selection, because it is a big part of the process. But a couple of tips. As an example, I've worked with organizations that have built their own feature store. It's certainly very custom. However, it's not core to their business, right? It's not part of their core business. And it also takes a lot of people to maintain, effort to maintain. It's also not like fully featured, of course, right? And there's a lot of companies out there that have built really solid capabilities in feature stores that really is their intellectual property, right? It is their business. It's their core business, is feature store, model registry, that sort of thing. So in those cases, I would typically take advantage of those solutions, right? Versus trying to build and package that yourself. Unless that's something that's part of your core business, I would typically rely on a product that it is their core business. They're going to continue to iterate on it for you and focus on your core business and your intellectual property. Another example is model training. As an example, setting up managed distributed training is really hard to do for yourself. Where you can choose to run something like SageMaker training jobs, and I promise that is the only AWS service reference I will use in this whole talk. But just to reinforce the concept, right? Like setting up some of these things is hard. When you can use a managed service to do it, I would just recommend kind of taking advantage of that inside your overall workflow. The next one is use tooling that gets you there fast, right, according to your business objectives. So for this, I'm talking a little bit more specifically about AutoML, pre-trained models to solve common use cases. A lot of times, you get into conversations and everyone kind of wants to be the hero to build the model, but there are a lot of really great pre-trained models out there, like AI services that can solve your use case. Get what gets you there fastest, right, and meets those business objectives. So with this approach, it's very likely that you'd fall into that hybrid category, right? Because in some cases, maybe you're going to use an AI level service for some use cases. Sometimes you're going to build custom models. In either case, you may still be building those the custom models and as part of your model build steps inside your overall workflow, especially when you're scaling use cases across an organization. Third, as you're making decisions between do-it-yourself, package or manage, and hybrid solutions, just make sure you're always looking at all costs of those solutions. And the reason I mention this is a lot of times organizations focus on the cost of the product itself or the cost of the service, but really you just need to make sure that you're actually looking at the total cost of ownership, right, as well. So what's the cost of maintaining your own servers in certain situations, maintaining your own custom developed components in some situations, and just make sure you're looking at that overall cost versus just the cost of the product or the service. And then finally, a lot of teams start with the goal of allowing complete flexibility to their data scientist teams to be able to choose and run any tool they want for model development. And while this may work in small organizations, when you're talking about large organizations or large enterprises, it will be tough to scale. It's tougher to scale when there's a trade-off between flexibility and standardization and speed. So it's tough to scale without standardizing on some things as an organization. So flexibility is important. I do not dispute that at all. It is very important. But you should look at and evaluate where it makes sense to standardize on certain things. Maybe that's a model registry, right? It will help you scale if you standardize to some degree. So now, Lesson 4. So although MLOps builds on DevOps practices, you can't just apply software development practices directly to machine learning. And that probably sounds very obvious in the room, but in a lot of my earlier engagements, or as well as in engagements now with companies that are just getting started, there is a tendency to kind of start to directly apply DevOps practices to MLOps. And it results in a lot of issues up front, I'll tell you that. And I see a lot of organizations do this. So a couple things to point out here. One, experimentation is key. And it needs to be done in an environment like we talked about that gives access to the resources they need, allows for rapid iteration. And what this means is typically for most data scientists, they're going to start out in their favorite tool. They're going to perform data analysis, feature engineering, training. They're going to perform multiple experiments. And in that early engagement I mentioned before, where they had built a process. So there was an engagement where they essentially built a process that mimicked their DevOps process for machine learning. So what it meant is every time a data scientist wanted to train a new model or evaluate a new model, they essentially had to take their training code, data prep code, check it into GitHub, and then it would run this formal pipeline, which, as you can imagine, if you've built a model before, is an extremely rigid process. It's one that doesn't scale well, and it's a great way to irritate your data scientists very quickly. So what we had to do is kind of work with them on the fact that MLOps is a bit different. And it would really kind of be the equivalent of taking your software developer, taking away any ability for them to locally test, and just like every little change you make for this one feature, you have to commit it to a full-on pipeline. And it doesn't work very well, right? It doesn't scale very well. So another key thing to know is a lot of cases, you don't start off by building a pipeline, right from the beginning. And this can be for a number of reasons. It can be because your data scientist doesn't necessarily have the skill sets to build a pipeline, or it doesn't make sense because there's some experimentation that's going to go on. I'll build a pipeline after I have a better idea what's going to actually work in this experiment. And that's completely okay, right? And also, not every model will make it to production, right? Not every model is intended to go to production. There are use cases that are more ad hoc. There's cases where that model is never going to be performing well enough. So you want to have that experimentation, the rapid experimentation, to really kind of test the feasibility, the viability of that model first. And then typically you go into creating pipelines once it is proven to be technically feasible. And the key here is that rapid experimentation, right, that we talked about. Let me go back one. Is the rapid experimentation. Like I said, a data scientist can run 76 different experiments. Maybe experiment number 56 was the best one. It's the one they want to move forward to production. The thing I would keep in mind there, as opposed to forcing it through a giant pipeline every time with every iterative development cycle for that data scientist, is putting in place really good experiment tracking. Because with experiment tracking, you can then take that model, number 56, version 56 that was developed, you know exactly how that model was built, you know how it's performing. You can then essentially move it on to the deployment part of the process. And like I mentioned before, it could be in experimentation, you're working with smaller data sets, you're not working with your full data set, but often you are working with your full data set as well. So if that model took, say, a week to train, like you don't want to go and retrain it like you would in like automated builds for software development, right? That's an expensive cycle. You need to be able to take that artifact and all of the information about that artifact and actually move it on to deployment. So second, pipelines. Like I mentioned, it's very possible that your pipelines won't be built during the model development, depending on your team's skill sets. In a lot of cases, data scientists we see will hand off their code to like an ML engineer. Do we have ML engineers in the room? Cool. Yep. Sometimes ML engineers building models, sometimes they're building pipelines, kind of doing everything. But basically, we'll see a lot of cases where a data scientist will then hand it off to an ML engineer who will build the pipeline for retraining, right? And in that case, one thing to note with pipelines in terms of like the differences obviously between the software development lifecycle is it's very common to have multiple pipelines, not just one single end-to-end pipeline. And the reason is for that is because, that workflow that we saw earlier, each of those steps has different life cycles in and of itself, right? So we very often see multiple pipelines used in terms of creating your machine learning pipeline. There could be a pipeline for data curation that runs a little bit more on your analytics side, creates that data set that's used for training. Then we see a training pipeline, then we see a deployment pipeline. And they're all triggered based off of different events or different occurrences, but it's pretty rare, I would say, for us to see a single pipeline end to end. Third, so similar to software development where you have that traceability, where you want to be able to trace all the inputs that went into a build artifact, it's similar to models, right? However, with models, it becomes a little bit more tricky, obviously, because of the number of versioned inputs that it takes from code, libraries, container images, actual data, as well as the outputs, the model artifact itself. So there's a lot more to manage, right? There's a lot more moving parts within there. So here is where we suggest, and it's one of the first things I usually talk to customers about, is if you don't have a model registry in place, get one, you need one. And it's really the only way you can scale and manage multiple model versions. So definitely highly suggest that for model governance and lineage. Finally, monitoring. So monitoring of models is very unique as well. When I mentioned the DevOps team earlier that didn't have a lot of machine learning expertise, that's a key aspect there, right? Is monitoring machine learning models is very different. So just make sure you identify, you implement all the monitors that need to be in place, collect the data that you need, and create alerts. Like I mentioned before, continuous training is not always the goal. So understand what your monitoring strategy is and what your retraining strategy is up front. So the final lesson, we made it to the final lesson finally. This one is small, but really important. And MLOps builds on DevOps practices, right, which includes an agile framework. So however, I often see a lot of teams with kind of that 5-year end goal as the starting point. And we get stuck in sort of this analysis paralysis of trying to architect a design or a solution that incorporates everything, from the get-go. And I've seen projects stall for months, for years, for this reason. So my final lesson learned is start small and iterate. And this is kind of a generic MLOps maturity model that we use. And within each of these categories, there's essentially underlying characteristics and practices within them to kind of loosely gauge an organization's MLOps maturity level. But often we see in the repeatable stage, you're incorporating automation, you're removing some of those manual handoffs. And then we see moving into the reliable stage where you're starting to incorporate some of those consistent mechanisms to track model lineage, governance, pipeline lineage, and incorporating some of those CI/CD practices like source and version control, automated triggers where it makes sense, automated quality gates like model performance or data validation. And then finally, the scalable stage. And this is typically aligned with creating and sharing patterns across your teams, across your organization. And it's likely when you're looking at this, you'd probably fall in different areas across each different kind of capability that you have, which is really common and really typical. But the caveat would be avoiding starting at the finish line, right? Avoid starting at the scalable stage and having that be your plan, and that's what you want to build out first. Pick out the practices that are most important to your business, and build out and up from there. It's a journey, as we all know, right? You can't start at the finish line and make progress quickly. So a quick wrap up. I know I'm short on time, or I'm out of it. I'm at 0 time. So these are the lessons learned that we went through. Hopefully there were some takeaways for everybody here. And finally, feel free to connect with me on LinkedIn. I love to connect with others in this space. And thank you so much. So sorry I went over on time. I owe you 5 minutes.